Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Zamri and my number metric is BE35202. Alright, so for today, I will explain about the project that my group do. Is it use a Python at Kaggle to detect a pneumonia bacteria in lungs. Alright, so first, we use a library uh, NumPy and Pandas. This is a linear algebra and data processing. This is a common libraries for numerical and data processing in Python. And then after that, the second cell is we use import PIL, which is this is a Python import Python imaging library. And then this is a TensorFlow, which is this a deep learning library, and we use a matplotlib.pyplot, which is this for plotting and visualizing data. So this is the coding. And then this line, which is for load to load samples images from the data set which pneumonia, which is, as you can see, after I press the image, the pneumonia image is looking at here, is displayed at here. And for this is to display a normal normal image normal, which is not effect with pneumonia. As you can see a difference, which is the color or at the lungs at X-ray. And after that, we used this for this cell, which the image data generator is for pre-processing the images, which is pre-processing images for the rescale 1 per 255, which is between 0 and 1. And then we use a flow from directory. These are three cell uh, for resize images 120 times 120, 120, 120. And then batch size, which use 8 for generator per batch. And we classification the binary for mode to binary classification. And then we use this for build a sequential model, which means layer added one by one, which is we use a convert 2D, which is 32, 64, 128, 256, and 512. And then 3, which is this is a kernel size. And then we use a ReLU, a flatten and dense for layer to convert the 3D output to 1D. Just this is the function of this coding. Then we summary that at here, as you can see, output shape, parameter, and for all. And then we use a model.compile. For this is for configure the model of for training. And for the training for cost 0.001, and we use the loss function for binary classification, and model will try accuracy as a metric here. And then this is for the trains the model on the training data. We use epoch 2 iteration over the entire data set, and the validation set after each push. As you can see, it takes 118 seconds and 143 seconds for each push. And then we evaluate the model performance on the test data and predict the generates prediction for the test data set. And this is the last coding at Python, which is this coding. The loop iterates over the test data, gets prediction, and visualize each image along with the prediction. It display the image, which is, as you can see, I put a 0.5. If the image above the 0.5, it it will detect it likely affected by pneumonia, and if the score is below is 0.5, the lung is likely not affected by pneumonia. As you can see at here, this is the image affected which not affected by pneumonia. As you can see, the image which a black color at lungs, and as you can see at here, it have a gray and uh, a light dark at here, but is likely affected by pneumonia, which is the score is 0.99, and as you can see at here is 0.855. It affected by pneumonia, and this is not affected by pneumonia. It have a 200 it have 200 or more picture at here. It's not mistake. As you can see at here, it detect all of this 0.4 is not affected by pneumonia, this is affected by pneumonia. Alright, so that's all from me.